Today we're going to be doing a review of operations with both fractions and decimals. I want to start by taking a look at some problems with fractions. And the first thing I'd like you to be able to do is to reduce or simplify a fraction. That means look for common factors or things that you can divide both the numerator and the denominator by. In this case, I might notice that 48 is divisible by 8. It's 8 times 6. And 64 is also divisible by 8. It's 8 times 8. And so I can cancel out that common factor of 8. And I'm left with 6/8. But I can actually go further in this case because 6 and 8 are both divisible by 2. 6 is 2 times 3. 8 is 2 times 4. And we can cancel out that common factor of 2. And that gives us an answer of 3/4. Now, had I recognized in the beginning that both 48 and 64 are divisible by 16, I could have done the problem in one step by just dividing by 16. You should also be able to take an improper fraction, and that's what I have right here in example 2. That's an improper fraction. And you should be able to convert that into a mixed number. The way to do that is to actually do the division to figure out, well, what do you get if you take 10 and you divide it by 3? Well, 3 goes into 10 3 times. 3 times 3 is 9, and you have a remainder of 1. So that means as a mixed number, we write down the quotient, 3, and then the remainder over that divisor, 3. So 10/3 is the same thing as 3 and 1/3. Again, that form was quotient is the big number, and then the little fraction is whatever the remainder is over the thing that you divided by, the divisor. You should be able to go in the other direction as well. If you want to take a mixed number like 4 and 2/5 and change that into an improper fraction, the fastest way to undo those operations is to take the 4, the big number, times the divisor. 4 times 5 is 20. And then you add that numerator 2, and that's 22. And so 4 and 2/5 is the same thing as 22/5. So again, I did 4 times 5, and then I added the 2. So let's review some of our operations with fractions. If we want to add or subtract fractions, we need a common denominator. Our fractions need to have the exact same denominator. And so in this first example, 5/12 minus 7/12, we have the same denominator. So we subtract the numerators. 5 minus 7 is -2. And then the denominator stays the same. So the answer would be -2/12. Now, you always want to reduce your fractions if possible. And in this case, we can divide both the top and bottom by 2. That's our common factor. And that leaves me with -1/6. So again, to add or subtract, we have to have the same denominator. If we don't have the same denominator, then we have to find a common denominator. So in example B, 3/8 plus 3/20. When you're trying to find a least common denominator, you are trying to find some number that's divisible by both of the denominators. So I'm trying to figure out, well, what number can I divide by both 8 and 20? And if you know what that number is off the top of your head, just by thinking about the times table, well, that's great. Then you know the LCD. In this case, some of you might recognize that 40 is divisible by both of these numbers. So 40 is the LCD. Now, it's not always easy to come up with the LCD in your head like that. And so there's another way you can find LCDs, and that's by creating factoring trees. So taking the denominators and listing all their factors. 8 is 2 times 4, and 4 is 2 times 2. So 8 is 2 times 2 times 2. 20 is 4 times 5, and 4 is 2 times 2. So 20 is 2 times 2 times 5. And then the idea is the LCD has to contain every factor of every denominator. So you start by just listing all of the factors of that first denominator. 2, 2, 2. And then you move over to the second denominator and you write down any factors that are missing. So I notice I've already written 2 2's down, but I haven't written that 5 down. So I'm going to tack on a 5. And if I multiply these numbers together, 2 times 2 times 2 times 5, I end up getting 40. So my LCD is 40. Then the idea is to take the two fractions, 3 over 8 and 3 over 20, and rewrite them so they have that LCD. So to turn an 8 into a 40, I have to multiply by 5. And so I'm going to do that to the top and the bottom. That gives me 15 over 40. And then I ask myself, well, how can I change a 20 into a 40? I have to multiply by 2, and I get 6 over 40. Now that I have the exact same denominator, I can add the numerators. 15 plus 6 is 21, and that denominator stays the same. So my answer would be 21/40. Let's do one more example like this. For subtraction, I have to have a common denominator. So I have to figure out, can I think of a number that is divisible by 9 and also divisible by 15? If you know that number, that's great. You have the LCD. If you don't know that number, well, 9 is 3 times 3, and 15 is 5 times 3. So the LCD, it has to have all the factors from the first denominator. And then when I look at the second denominator, oh, I already have a 3, but I need a 5. So 3 times 3 is 9, times 5 is 45. Oh, so 45 is divisible by both 9 and 15. Okay, so then I have 1/9 minus 2/15. If I want to turn a 9 into a 45, I have to multiply by 5. And I have to do that to the top and the bottom. That gives me 5/45. And then to turn a 15 into a 45, I have to multiply by 3. That would be 6/45. And now that the denominator is the same, I can subtract the numerators. 5 minus 6 is -1. Denominator stays the same. Now, if you want to add or subtract with mixed numbers, I think the easiest way to do that is to just change these into improper fractions, and then you don't have to learn anything new. You don't have to change them into improper fractions, but there are some cases, especially some types of subtraction problems, where it'll be a lot easier to do so. So let's see. 2 times 4 is 8, plus 3 is 11. So 11/4 minus 4 times 2 is 8, plus 1 is 9, 9/2. Now for my LCD, I want to know what number is divisible by both 4 and 2. And this one I can do in my head. I know that 4 works. 4 is divisible by both 2 and 4. So my LCD is 4. I don't have to do anything to 11/4, but I'm going to take the 9/2 and multiply the top and bottom by 2. And that gives me 18/4. Now that the denominators are the same, I can subtract the numerators. I get -7/4. And to finish, if you have a problem that starts with mixed numbers, I would like you to give your answer as a mixed number. So 4 goes into 7 only one time, and it's negative, with 3 left over, so it would be -1 3/4.